Hello everybody, once again have a nice day. So today we will discuss the equation of a straight line in space. That means we will discuss the situation of a straight line in space. Dear students, as you know, the equation of the straight line in two-dimensional geometry in the standard 11. You know the 1-point form, you know the 2-point form, you know the slope-intercept form, you know the intercept form, you know the normal form, different forms are there. So whatever it may be, but before going to find the equation of a line, we need one particular thing that is called the locus point. And in two-dimensional geometry, you have taken the locus point P, where is x comma y. That's why every equation of the straight line coming something x plus something y is equal to dash, is equal to something. So that x comma y is nothing, that is the locus point. So before coming to the straight line, so let us write locus point in a space. Locus point in space. Locus point in space will take P with the coordinate x comma y comma z. If that x comma y comma z is the coordinate of the point P, then any vector, suppose r vector, will represent, that is xi plus yj plus zk. That means the point P must be represented by the vector r vector. So r vector is representing xyj, that is the position of the point, and r vector is equal to xi plus yj plus zk, that is called the position vector of the point P, and that is called also the locus vector, or it is representing the locus point of the particular point in form of vector. So though P having the coordinates x comma y comma z, these are called the Cartesian coordinates, and that this x y z is expressed in form of r vector. So the r vector is the vector form. So this is the Cartesian form, locus point, and this is the vector form. So it clearly indicates that throughout this chapter we will read two types of equation of each. So we will check the equation of the straight line in the two form. One is Cartesian form. Cartesian form means in form of xyz, and another is the vector form where r vector must be there. So we will discuss here the 2 points, that is, one is two ways of the equation in two form we will discuss throughout this chapter. First one is Cartesian form, the second one is the vector form. In Cartesian form, the locus point is x comma y comma z, and here the locus vector is r vector. So Cartesian form and the vector form. That means the equation of the straight line will read in the two form. One is the Cartesian form, another is the vector form. So let us come to the 1-point form of the equation of the straight line. 1-point form. So 1-point form in 2D already you know, that is the line passes through a particular point with the coordinate x1, y1, and the line must have the slope. Slope means making a fixed angle with the positive direction of x-axis. So here also in one point form, the line passes through a particular point. Suppose this is C. I am taking this is a line. Let this is the line. It is passing through the point. You just see the tip. It is passing through this point, particular point. And suppose I will make a particular angle with x-axis. Suppose the particular angle x-axis. That is with positive x-axis is making some angle. So let us see by assigning the same thing what we have given in the 11th class, whether the position of the line in space is fixed or not. If the position of the line in the space is not fixed, then we cannot find its equation. So you just remark here. You mark here, this is my tip making angle theta with x-axis. Suppose I will make like this way. In this direction also, the same angle is maintaining and the same point is there. But the position of the straight line is not constant. It is variable. So it will be variable like this way. That means the slope angle in case of a line in space is not working. So instead of the slope angle, if this line will be fixed by the angles made with x-axis, y-axis and z-axis, then it cannot move away. It cannot move or you cannot change its position. So instead of taking the angle in x-axis, it must be bounded with the angle with x-axis, y-axis, z-axis. Again the concept of the direction cosine, or again in the concept of the direction ratio. So my dear students, the 1 point form what is telling, the first requirement is passes through a point A with the coordinate x1, y1, z1, or a point with position vector A vector, where A vector is equal to x1, y1, z1. And I am taking simultaneously for the Cartesian and for the vector also. And the second point is parallel to a vector, say B vector. Means the line is passing through a point and parallel to a vector. If it is passing through a point and parallel to vector, the coefficient of the ijk is a direction ratio. If that vector is fixed, then the direction ratio with respect to this given line will be fixed. That means indirectly the line is bounded or binded with some angle with x-axis, some angle with y-axis and some angle with z-axis. So let us see, look at here. Suppose this is the line. And let us assume this line is passing through this point. Let this line is passing through this point. Line is passing through this point. I am showing this red one. Line is passing through this point. And this is a vector and parallel to the line. So you cannot change now the position of the line, because passing through the point and parallel to the vector, you cannot change the position of the line. And though the position of the line cannot be changed, then the equation of the line can be obtained. So the necessary condition to find out the equation of line in space is passing through a point with the coordinate x1, y1, z1, or the corresponding position vector is a vector, and parallel to a vector. It is the parallel to a vector, that vector is a B vector. Then let us see how you are getting the equation of the line. So first will come out in the vector form. So let us draw the figure. Say I am taking out so this is the Cartesian coordinate x coordinate, this is y coordinate and this is z coordinate. This is say origin. Let the line is this one, this line passing through the point A with position vector A and parallel to a line. This line is parallel to this line, parallel to this line, parallel to this line, parallel to this vector, parallel to this vector, the vector name is B vector. So once again, the line passes through the point capital A with the position vector A vector and parallel to another vector, parallel to the vector B vector. So this condition is given to us. So I can choose any point on it named as a locus point. So locus point R vector. So P is any point on the given line, that is called the locus point. So now I am discussing the vector form of the equation. So let us look at here in this line. So in this line, this is the particular point, fixed point through which the line is passes. This is the locus point. Locus point you can take on any point on the line. If you join A with P, you will get a vector. A with P, you will get a vector. So AP vector will be R vector minus A vector. AP vector is R vector minus A vector. And if the vector B vector is parallel to the line, obviously B vector will be parallel to the AP vector. So I can say AP vector is parallel to B vector. Yes or no? The condition was given. The line is parallel to the given vector B vector. On the line, AP is a vector coming out, that is R minus A, and AP vector is parallel to B vector. And also we know, if the two vectors are parallel to each other, one will be scalar multiple of other. If one vector is parallel to other, then I can write here AP vector is lambda times of B vector. So lambda is a scalar. Lambda belongs to any real number, where lambda belongs to any real number. So AP vector means R vector minus A vector is equal to lambda B vector. That is equal to R vector is equal to A vector plus lambda B vector. So this is the equation of the line in vector form in space. Equation of the line, straight line in vector form R vector is equal to A vector plus lambda B vector. Once again I am reminding you students, this is the one point form to find out the equation of a straight line. What was given to us? It was given that the line is passing through a fixed point, that is A vector, and a parallel to a fixed vector, that is B vector. These two things are given to us. We have chosen any point on the line, that is the locus point. Joining A and P, we got a vector on it. That name of the vector is called AP vector. And AP vector is parallel to B vector, though the line is parallel. So I have written AP vector parallel to B vector. If the two vectors are parallel, one is scalar multiple of other. So AP vector R minus A vector is equal to lambda B vector. So R vector is equal to A vector plus lambda B vector. This is the vector form of equation of straight line. This is the vector form of the equation of the straight line in space. So let us convert this vector form to the Cartesian form. So Cartesian form means we will use x, y, z or x1, y1, z1. X, y, z. Let the coordinate of this point will be x1, y1, z1. And the locus point P will have x, y, z. Let the B vector is equal to alpha I, beta j and gamma k. So I am converting to this Cartesian form. So I am writing let B vector is equal to alpha I plus beta j and gamma k. And A point is x1, y1, z1. And understood the locus is x, y, z. And the locus point is say x, y, z. Now we are ready. Now we are ready to convert it to the Cartesian form. In place of r vector, what should I write? In place of r vector I am writing here r vector is xi plus yj plus zk is equal to a vector x1i y1j plus z1k plus lambda times b. B means alpha I, beta j, gamma k. So I have replaced all those things. Then I am converting. I am replacing all those things. So I can write here x minus x1 I plus y minus y1 j plus z minus z1 k is equal to right hand side lambda alpha I beta j gamma k. And comparing, because the left hand side vector x minus x1 I plus y minus y1 j plus z minus z1 k is equal to lambda whole into alpha I plus beta j plus gamma k. The left hand side one vector, right hand side another vector. If the two vectors are equal, then their coefficient will be equated. Then the coefficients will be equal. So comparing the coefficient, what I got, x minus x1 is equal to lambda alpha, or I can get x minus x1 by alpha is equal to lambda. Similarly, y minus y1 by beta. Similarly, z minus z1 by gamma is nothing, that is equal to lambda. So, my dear students, once again you see the derivation. I have put the Cartesian form of R, Cartesian form of A and the vector B in the component form alpha I plus beta j plus gamma k. Comparing both sides, I obtained this one. So x minus x1 by alpha is equal to y minus y1 by beta is equal to z minus z1 by gamma is equal to lambda. This is the equation of the straight line in space. It is a Cartesian form and it is the vector form. This is the Cartesian form and this is the vector form. So now we will analyze what is what. I am writing in the shortcut. Only I am keeping those things. So what is required for us? So once again, it is vector form. And this is your Cartesian form. Cartesian form. Now we will analyze little. We will analyze little what is what. Look at here. X minus x1. x1 is the fixed point coordinate. x1, y1, z1. Where it is coming? That x1, y1 is z1 is coming through which fixed point the line is passes. And you see the denominator. Alpha, beta, gamma. Alpha, beta, gamma is what? Now alpha, beta, gamma is the direction ratio of the vector which is parallel to the given line or the required line. So that alpha, beta, gamma is in the denominator and the fixed point coordinates is in the numerator and is equal to lambda, that is a constant. So again you may think, sir, if alpha, beta, gamma is there, alpha, beta, gamma is any real number. Alpha may be 0, beta may be 0, gamma may be 0. If one of them will be 0, you don't pursue that, in which we are telling something by is non-defined, but you have to accept here something by 0 is acceptable here. We cannot say it is non-defined because these are representing the direction ratio of a vector. The direction ratio of the vector, one of the component may be 0. Suppose one vector is on the x-axis. Sorry, xy plane. If the vector is on xy plane, so to that vector many lines will be parallel. So those lines will be parallel to a vector lying on xy plane. In xy plane, the gamma coefficient will be 0. So at that time we accept that z minus z1 by 0 is equal to lambda. And though they are in the equated position and equated to something, if something by 0 is coming, then we will do the cross multiplication. But we should not write non-defined. Okay. So this is the standard form of the equation of the straight line in Cartesian form. This is in the vector form. Now we will see how to convert the equation of the straight line in one form to another form. In one form to another form, how will convert? I am just writing the vector r vector, equation of the line in the vector form. R vector is equal to a vector plus lambda b. This is in the vector form, and here x minus x1 by alpha, y minus y1 by beta, z minus z1 by gamma is equal to lambda. This is the Cartesian form, this is the vector form. Correct? Both are the standard equation. Standard form of the equation of a line. Okay. R vector is equal to a vector plus lambda b vector, that is the vector form, it is Cartesian form. And both are the standard form of equation of the straight line. So we will take some example. We will take some example before the conversion. So write the example, question number 1. Write the equation of the straight line. Write the equation of the straight line. Write the equation of the straight line passes through say 2, -4, 6 and a parallel to the vector say 4i minus 3j plus 2k. Write the equation of the straight line passes through the point. This is the point. And parallel to the vector. This is the vector. So that means it is x1, it is y1, it is z1. x1 is 2, y1 is minus 4 and z1 is 6. So I am writing first the Cartesian form. I am writing here the Cartesian form. So you can write here x1 2, y1 minus 4, z1 6, and it is your B vector. B vector already it is alpha, beta, gamma. So I can say alpha 4, beta minus 3, gamma 2. So now we write the equation. Now the required equation x minus x1 2 divided by alpha 4 is equal to y minus y1. y1 is minus, so minus minus plus, so y plus 4 by beta is minus 3. Z minus z1 is 6 by 2. So this is the required equation of the line x minus 2 by 4 is equal to y plus 4 by minus 3, z minus 6 by 2. Check whether it is correct or not. Check. Passing through this point and parallel to the vector. Passing through the point parallel to the vector. So this is the Cartesian equation. This is the Cartesian equation. You will write the vector equation, so it will be converted to the vector. That will be your A vector. A vector is equal to 2y minus 4j plus 6k. So 2y minus 4j plus 6k. I am writing the vector form here. Vector equation. R vector is equal to A means the point. Point is 2i minus 4j plus 6k. Then lambda times B vector is already given 4i minus 3j plus 2k. This is the vector equation and this is the Cartesian equation. So if the point is given and if it is parallel to a vector, then we can find the equation of the straight line. One is Cartesian form, another is vector form. Already the two form equations is shown in the board. This is the first question that we have discussed. Write down carefully, quickly. Then we will go for the second type of question. This is the first type of question, it is a fundamental question. We will go for the second type of question. Second type of question is what I told earlier, conversion. If the Cartesian form will be there, how to convert to vector form. If the vector form will be there, how to convert the Cartesian form. Ready? Okay. So I am writing the question number 2. Write the question number 2. First I am taking one vector equation, then it will be converted to the say Cartesian form. Question number 2. Write the equation in Cartesian form. The equation is R vector is equal to 2i plus j minus 6k plus lambda times I plus j plus 3k. So this is the A vector. So A vector will represent x1, y1, z1. And this is your B vector. B vector is I plus J plus 3K, that will represent alpha, beta, gamma in the Cartesian form. So directly I can write the solution, the Cartesian form, is, you see, x minus x1 2 by alpha I, coefficient of I is 1, is equal to y minus y1. In place of y1, 1 is there. So y minus 1 by beta means here 1, z minus z1 is minus 6, so minus plus 6 by 3, x minus 2 by 1, x minus 2 by 1 is equal to y minus 1 by 1 is equal to z plus 6 by 3. This is the vector equation to the Cartesian form. Now we will see Cartesian to vector. Take another example. Question number 3. We will move very slowly because this chapter is like that. Very interesting if you will understand from the beginning. Write in vector form of the equation of the line. Write the vector form of the equation of the line. So equation of the line is 2x minus 4 by 6 is equal to say y minus 2 by 1 is equal to 5 minus z by minus 3. Look at here. So this is the equation of the line in standard form, that is in the Cartesian. You just compare the Cartesian. In Cartesian, the coefficient of x, y and z are exclusively 1 because x, y, z is the locus points. If you bring to the standard form, the coefficient of x, y, z should be exclusively 1. But you see the question. In the question, the coefficient of x is 2. It must be done 1. So to make the coefficient of x is equal to 1, we have to divide everywhere by 2. So if you divide everywhere by 2, then it will become 2x by 2. So 2x by 2 minus 4 by 2, 6 by 2. Again y minus 2 by 1, it is in the standard form because the coefficient of y is equal to 1. Always you will see the coefficient of x is equal to 1, coefficient of y is equal to 1, coefficient of z is equal to 1. But the third one you see, the coefficient of z is minus 1. It is not allowed. Coefficient of z will be exclusively 1. So I will take the minus common. So z minus 5 by plus 3. Now the equation converted to 2 cancel. So x minus 2 by 6 by 2 is coming 3 is equal to y minus 2 by 1 is equal to z minus 5 by 3. Now it is coming to the standard form. After coming to the standard form, then only you can think about the conversion, otherwise not. So I can write now vector form. Now write the vector form. Vector form, r vector is equal to a means x1, y1, z1. So that is equal to 2y plus 2j plus 5k plus lambda times b. B means denominator, that is 3i plus j, 3i plus j plus 3k. So 2i plus 2j plus 5k, point through which the line passes. The second one is plus lambda times the denominator 3I, right? Then 1j, right? Then 3k. So this is the conversion of the Cartesian to the vector. So dear students, we have seen the two cases. One is Cartesian to the vector, vector to Cartesian. And before that, one example I have given, that is if the line is passes through a point and a parallel to a vector, directly you can find the equation of the straight line either in the vector form or in the Cartesian form. Okay, so that three examples I have given. So this is all about the 1 point form of the equation of the straight line. Let us move to the 2 point form of the equation of the straight line. 2 point form. Write down 2 point form. 2 point form. So what will be given here? The line passes through 2 points. Passes through the point A with coordinate x1, y1, z1, and another point B x2, y2, and z2. So here only the 2 points are given, but the parallel vector is not given. So let us come to the figure. The line is passing through 2 points. So this is the coordinate axis x, and it is y, say it is z. I am taking any line. On the line, 2 points are already given. Let the 2 points are like this. Point A with coordinate x1, y1, z1, and point B with x coordinate x2, y2, and z2. So here the line is not parallel to any vector, not required also. And by the way, we will take the locus point anywhere. Let this is the locus point P, x, y, z. X, y, z. So dear students, 2 points are already given to us. And if you will join AB, AB will be a vector. So what is the name of this AB vector? x2 minus x1 I plus y2 minus y1 j plus z2 minus z1 k. So AB is a vector. AB is a vector on the line. If AB is a vector on the line, it will be also treated as the vector which is parallel to the line. So AB vector is on the line, it will be treated that it is also parallel to the line. So indirectly we will get a vector which is parallel to the line. So what is the name of this vector? The name of the vector is AB vector. So in place of B vector, now we got the AB vector. Now it is converted to the 1 point form. 1 point form is what? Now out of these 2 points, we can use 1 point and the locus point is there. So now so now I can write here AB vector is also parallel to the given line. It is parallel to the given line. So by 1 point form, we can write the equation. Suppose I am choosing this point, this one. I am choosing this point A, x1, y1, z1. You can choose also x2, y2, z2, no issue. I am choosing x1, y1, z1. Means passing through the point x1, y1, z1 and parallel to the vector AB vector. So the equation will be x minus x1 by alpha. This is alpha, this is beta, this is gamma. So x minus x1 by x2 minus x1. Similarly, y minus y1, y2 minus y1, z minus z1 divided by z2 minus z1. So my dear students, the 2-point form is converted to the 1-point form. As the 2 points, those are lying on the line, if you join these 2 points, it becomes a vector. And the vector is fortunately lying on the line, and those are lying on the line that can be treated as parallel to the line. So AB vector is treated as parallel to the line. That is alpha I, beta j plus gamma k, what we are calling B vector, small b vector. So converting to the 1-point form, we got x minus x1 by x2 minus x1, y minus y1 by y2 minus y1, z minus z1 by z2 minus z1. It is the equation of the straight line in 2-point form. The equation of the straight line in 2-point form. So today we have discussed the equation of the straight line. First you realize the slope is not working on to find out the equation of the straight line in space. So in place of a slope, we are finding a vector which is parallel to it. Point number 1. Point number 2, that we have found the equation in the standard form. That is passing through one point x1, y1, z1 and parallel to a vector B vector. And it has 2 equations, one is Cartesian form, another is vector form. Vector form already discussed, r vector is equal to a vector. What is a vector? Now through which the line is passes through the fixed point, plus lambda times of the B vector. B vector is what? Now vector which is parallel to it. So this is the line, it is the B vector. This is the B vector and it is always parallel to it. So to converting to the Cartesian form, what we got? Now x minus x1 divided by alpha is equal to y minus y1 divided by beta, z minus z1 divided by gamma is equal to lambda, the constant. Then secondly we got the 2-point form, that is passes through the point x1, y1, z1, x2, y2, z2, and this is the finally the equation of the straight line in the 2-point form. So thank you very much. Already we have discussed 3 questions and some questions I am giving to you in the assignment form. I hope you will finish, and this is the beginning of this straight line, then gradually we will move. Thank you very much for your patience hearing. Thank you.